Okay, in this video, we are going to solve logarithmic equations and identify extraneous solutions, and we're going to solve these two problems. But before we solve these problems, it's important to get some background information. So extraneous solutions, I like to think of them as bad answers in that they don't exist. And for logs, the inside piece must be greater than 0, and I'll show you why it has to happen. So this is a graph of log of x. And you notice it never touches this 0 and it never goes to negative. Like you can never get log -1. It's not even in this graph, or log -2. So you can't have any negative values. Likewise, at 0, it never touches. It gets closer and closer. Like you can't have 0, but you can have 0.0000001. And so with extraneous solution, it gives us some limitations in that this value of x cannot be 0 or it can't be any negative numbers. Okay, we've seen this before in one of our log videos. We're going to also use this whenever we solve logarithmic equations. And so let's get started. This is our first problem. This is easier than the second one. Second one, we're going to use more of these kind of properties. But you notice here we have a log parentheses x. Here you have a log parentheses x squared plus 5x minus 12. So in short, you can ignore the log because essentially they're both the same, except he's x and he's x squared plus 5x minus 12. The log they both share, and so you can kind of ignore it. Or if you want to, you could put a base 10 on both sides, and it would cancel out using one of these log properties. So we focus on the inside piece. So x is equal to x squared plus 5x minus 12. And the way we're going to solve this problem is ultimately by factoring. So we want to make one side equal to 0. So we want to get rid of this positive x, and we can subtract x on both sides. So we're going to get x squared. 5x minus 1x is positive 4x, and negative 12 is equal to 0. Okay, at this point, we're going to factor, and I have a lot of playlists on how to factor. So I'm going to use the mental method. So I'm going to put a parentheses x, parentheses x, and I'm going to think to myself, what number times itself gives us negative 12 but adds to give us 4? And we know it's going to be positive 6 and negative 2. Negative 2 times 6 is negative 12. Negative 2 plus 6 is positive 4. And a big thing that we learned this year is that if this piece is 0, 0 times any number would give you a 0. Likewise, if this piece is 0 and this is like a billion times 0 is still 0. So we need to think, how do we make this piece 0? What value of x makes it 0? And we know it's going to be x is equal to 2 because 2 minus 2 is 0. We're going to do the exact same thing for this piece. What value of x makes this piece 0? Now if x is negative 6 plus 6 is 0. So those are our two answers. But with logs, there are limitations. There are the extraneous solutions. And we have to remember, for logs, the inside piece can never be negative or 0. So if we're saying x is equal to negative 6, I put in a negative 6, right away we know that this won't even exist. Log negative 6 doesn't even exist, so this is called an extraneous solution. Now we have to try 2 to make sure it works. So the first one, I can put a 2, and it works. Now we need to make sure that this piece right here will also give you a positive 2. Let's try it out. 2 squared plus 5 times 2 minus 12. 2 squared is 4, plus 5 times 2 is 10, minus 12, and 4 plus 10 is 14. 14 minus 12 is 2. And we said this piece was a 2. And so when x is equal to 2, both of them will be a 2. This will also be a 2, and it actually works. So our only answer for this problem is x is equal to 2, and that x is equal to negative 6 is called an extraneous solution in that it does not exist. Okay, this is our second problem. It's going to be more involved. Our last problem was easier because each piece had a log. This piece does not have a log. So we're going to actually apply several of these log properties. So the first one we're going to do is we have a log base 3 of x plus log base 3 parentheses 2x minus 3. So they both have the same base of 3. So we're going to apply the product property. So we're going to write it as log base 3 parentheses x times parentheses 2x minus 3. We're going to combine them using this log property right here is equal to 2. And we can expand a little bit, so we can say log base 3 X times 2x is 2x squared. X times negative 3 is negative 3x. Close parentheses is equal to 2. Now, if we want to get rid of this log, we can apply the inverse property. And we're going to use this property right here. So if I want to get rid of this log base 3, I can put a 3 below the L like this. And if I do it on one side, I have to do it on the right-hand side. So 3 raised to 2. By doing this, this piece is canceled, and we get 2x squared minus 3x is equal to 3 squared is 3 times 3, which is 9. Now this problem is, getting closer to being normal. We want to get rid of this positive 9 to make it 0, so we can subtract 9 on both sides. So we get 2x squared minus 3x minus 9 is equal to 0. And now we're going to do the whole factoring business. So we'll put a parentheses 2x times parentheses x close parentheses is equal to 0. So we wanted to multiply to give us negative 9 and add to give us negative 3. Now if I try this, negative 3 plus 3, 3 times negative 3 is negative 9. That's right. 2x times negative 3 is negative 6x. X times 3 is 3x. And negative 6x plus 3x is negative 3x. Again, if factoring is kind of difficult for you, I'm going to have a playlist on how to factor. But this video, the main objective is to solve logarithmic equations. So I'm assuming you know how to factor. Now we're doing the same thing as last time. We want to make this piece equal to 0. We want to make this piece equal to 0. So 2x plus 3 is equal to 0. So we know it's going to be x is equal to negative 3 divided by 2. If you want, you can think about this. 2 times negative 3 divided by 2. The 2's cancel and you get a negative 3. And negative 3 plus 3 is 0. And we want to make this piece equal to 0. And we have a negative 3, so it's going to be positive 3. And we're not done yet. We had to actually plug it back into the original equation. It's important to note you won't always reject the negative value of x because in some problems, the equation could be like negative 2x, where when you plug it back into the equation, you're multiplying a negative times a negative and you get a positive. Not necessarily in this case, we'll try it, but it's very important that you have to plug it back into the original equation. You can't just see, oh, it's negative, I'm going to say it's an extraneous solution. You have to plug it back in. Because if the equation was negative 2x and then you plug it back in, a negative times a negative is a positive. Okay, so we're going to plug it back in. Right away, I put in a negative 3 divided by 2. You can't have a negative inside, so it's going to be an extraneous solution in this case. Now we'll try 3. Log base 3 of 3 plus log base 3 of 2 times 3 minus 3. Is it going to be equal to 2? We don't know that yet. So log base 3 of 3, that's like saying 3 raised to a question mark is equal to 3. So this is going to be 1. This piece right here is 1. We got to try this piece too. So 2 times 3 is 6. 6 minus 3 is 3. So it is the exact same thing. Log base 3 of 3. And this is also equal to 1. And 1 plus 1 is 2. And we have 2. So that is the correct answer. The correct answer for this problem is x is equal to 3, and that x is equal to negative 3 divided by 2 is called an extraneous solution. And that's pretty much it to solve logarithmic equations and identify extraneous solutions.